Hi friends, we're going to do notes on notability this time, and I think it should work. Well, I should tell you that I already made one and I didn't have the sound on, so just 15 minutes of my life just gone, but it worked okay. So I'm going to go through the notes here. Of course, feel free to pause it whenever you want. In the meantime, I'm going to draw some things on this slide in Notability with my pen. If you want to just copy it into your notebook with regular pen and pencil, that's fine. If you want to use Notability, there's a blank one on Schoology as part of this assignment that you can, it's not an assignment, as part of these notes that you can use to import into Notability and write on if you want to. Hey, it's up to you. All about options 2020. So let's go through. We were talking about matter in the last lecture and what it is, which is basically everything that takes up space and has mass. And we're going to get into describing it today, and then also doing some things with some numbers that I think you've been doing since third grade, so I think you'll be okay. Okay, so matter is described two ways, quantitatively and qualitatively. Qualitatively is like with words and terms that you may understand, like heavy, rough, light, smooth, soft, stuff like that. Words that you definitely help to describe what's happening, but are not really comparable. Like, what does tall mean to you? How tall is someone who's tall? It might be different things to different people. So we use quantitative terms to get around that. Quantitative terms are ones that use numbers and units, and so they are the ones that are more commonly used in science, although both have their place. So something like, I'm 5 feet 11 inches tall, so I use the numbers and I use the units that go along with them. I weigh 150 pounds or whatever. So that is another way that you say, like, have numbers and units to make it make sense. The idea is that you can use both, but the second one is the one that's more commonly used in science classes. You can also describe matter by their chemical or physical properties. The physical properties are the ones that you can determine without changing the identity of the substance. So, for example, I can take a substance, I can put it onto a balance and determine its mass. I can measure its length and width and height and find its volume. I can boil it and figure out what its boiling point is. All of those don't change the identity of the substance, and those are called physical properties. Chemical properties are the ones you don't know. You don't know unless you either do an experiment or look it up in a book. And to look it up in a book, even then, an experiment was done at some point to say what the properties are. So, for example, I don't know that gold is not going to react with water unless I take the gold and I put it in water and I notice nothing happens. I don't know that a block of sodium is going to explode when I put it in water unless I take some sodium and I put it out into some water and watch it explode. So those things you would determine either by an experiment, and you can't tell them necessarily by looking at the object. You might not be doing the experiment, maybe it's been done in the past, but someone has done the experiment, so you know the chemical properties of something. Both properties are very important. Chemical properties obviously important for when we use objects in our lives, like, for example, your iPhone battery. It gets warm, but it would be bad if it caused your hand to melt or caused your phone to melt. So they pick lots of substances based on their chemical properties for things that we use every day. In this class, we'll often use volume and mass to describe some matter. Volume, there's lots of ways you could do it. If we were in class, maybe we would do displacement. Like, if you've ever taken a odd-shaped rock and put it into water, you can see how far the water level goes up. That's called displacement. It's a good way to measure volume. If it's a prism or a square, it's length times width times height. If it's a sphere, it's 4/3 pi or a cube. So if it's a geometric shape, there's an equation to determine what the volume is. Mass, we do with a balance in class. Mass and weight are different. Mass is how much matter is contained in something, and weight is your mass times gravity. So we use weight commonly on Earth because the gravity on Earth doesn't change, but in the universe, gravity is different depending on where you're at. So mass is more commonly used in terms of, especially in physics, and then this class as well. Whoopsies. So that's how you would do mass. Okay. You probably are familiar with the metric system. It is a system that pairs a prefix with a suffix. The prefix determines the scale, the suffix determines the type of measurement. So, and maybe you've heard of like what a millimeter is. A millimeter literally means, well, hey, what's this one? Let's go crazy. Milli is just the prefix for like 1/1000th, and then meter is another prefix, and meter means distance. So that a millimeter is literally measuring 1/1000th of a meter. Okay. Abbreviations work the same way. The M here stands for milli, and then the L stands for liter. So they're different, but they both mean the same thing. The first letter is like the scale, and then the second letter is what type of thing you're measuring. Don't feel like you need to write this whole table down, okay? You can, I'm not going to like make you write the table down as part of a quiz or test or something, but it's useful to know some of these things, and you're probably already familiar with them as well. These are 5 metric units that we use in class very commonly. So for length, you've got length, the L is what the symbol would be in like an equation. So like length times width times height, L times W times H. And then the abbreviation would be M for meters. So that's how all these things fit together. It gets confusing because a lot of the same letters are used, which is not very convenient. For example, mass here, the mass is M in an equation, like the potential energy of a substance is mass times gravity times height, mgh. But when we talk about like actually measurement, what we abbreviate, like if something weighs 30 grams, we would say 30 G for grams. So it's kind of confusing because, as I said, the letters tend to repeat in some situations. But you're familiar with length and mass. Time would be seconds. We don't use time a ton in chemistry, but it can be used for certain reactions to determine rates. But if you take physics next year, or you took physical science, you would use time very commonly. Temperature, you're probably like, what's Kelvin and Celsius? Kelvin and Celsius are the 2 approved ways to measure in the metric system. This might surprise you, but America, of course, is the only place that uses what we call the imperial system of measurement, Fahrenheit, which is not great. So everywhere else in the world uses the metric system, or the System International. That's what that stands for. But Kelvin or Celsius, they're related. We'll get to it later, but those are the 2 that we would measure temperature. And then amount of substance is the one actually we'll use the most in here, and it's the one you've never heard of. Amount of substance is called the mole, and that's how you measure chemical quantities in this class. So we'll use the mole a lot, actually, but not yet. Prefixes, again, don't feel like you need to copy these down. This is the section that you should be familiar with. It would be like, not my best work. Inside the square. Should I erase it? Oh my gosh, it's going to work. Oh, nailed it. Okay, I'll try again. I'll do better. Strive to be better. You know what? It's not much better. We're going to be honest. These are the 3 that you need to know. Kilo, centi, and milli. Sorry that micro is highlighted. You don't really need to know micro. They're good to know all of them, but the 3 that we'll use the most are kilo, centi, and milli. So eventually you're going to be good enough that you should be able to convert between them, and I'm going to show you how to convert in just a moment here. You've heard of all of these. Kilo means 1,000th of, centi means 100th of, milli means 1,000th of. Again, a lot of the numbers are repeated. You'll see M here, which gets kind of confusing, or capital M. Just be aware of that. And when you're talking about scientific notation, metric prefixes, the capitals and lower cases mean different things. You might notice here this strange letter, like a U with a tail. That's called the Greek letter mu. It's the lower case of the Greek letter mu, and that means micro. It means 1/1,000,000th of something. Some of these words maybe you've heard, like giga and mega. Like if you have we all have iPads now, so the iPad has like 64 gigabytes of memory. Giga is the prefix, that means billion. And then bytes is how you measure digital information. So gigabytes just means 1 billion bytes. And there's even more than that. They go above this as well. You have more numbers here, and you've got smaller numbers down there. But maybe you've heard of like tera. If you are a computer nerd, you know that you can buy hard drives that are terabytes, which is 1,000 gigabytes, which is also what comes after a billion, a trillion. So a trillion bytes is a terabyte. And anyway, they're all related. They're just steps and powers of 10, as you can see in the last column right here. They're just powers of 10. Not all the steps of 10 are numbered. That's why it goes right from mega to giga, for example, or from nano to pico or micro nano. Sometimes they're just named in steps of 3. But the ones in the middle, these guys right here, there's other ones that have names, but they're not really important for this class. But the 3 that you need to know are the ones that are inside the square that I drew terribly twice, and I apologize. We're moving on now. Excuse me. Okay. It's important, like I mentioned, to be able to convert either in your head or have a tool available to do it. When we're talking about converting, really, we're just talking about the ones I care about are the ones really right there in the middle. So it's not too much to memorize, but to help you, a number line is really useful. You can refer back to the number line if you want to, or just draw one in your notebook that you're going to have that you can use. So I'll draw my number line here, crushing it so far. In the middle of the number line, you've got the base units. And the base units that we use in this class are usually liters, meters, and grams. And that's a capital L, this is a capital, or lowercase m, this is a lowercase g. And those are the three that are most common. And we're not going to do the entire number line, but we'll just do the big parts here. So you'll draw 3 lines. This second line to the right here, that is centi. So I'm going to write like this. And then this is milli. Centi is a C, milli is an M. And then it goes further, 1, 2, 3, that's micro. That's the mu with a tail, or the mu, yeah, U with a tail. And there's more there, but we don't need to name them. And then on this side, you've got 1, 2, 3, that's kilo. K-I-L-O, it's a K. And 3 more is mega. G-A with a capital M. And you get the idea. You can even put the powers of 10 in here if you wanted to. This is 10 to the 6th. This is 10 to the 3rd. Technically, this is 10 to the 0, which is 1. This is 10 to the negative 2. 10 to the negative 3rd. 10 to the negative 6th. Okay, it's kind of messy. But you get the idea. Hopefully you see the number lines. When you want to convert, the thing that you do is you just count on the lines. So I'm just going to kind of move this a little bit this way. So, for example, if I said, well, if you run cross country, you run a 5. That's not a 5. You run a 5 kilometer race. So, abort. Okay, 5 kms. That means 5 kilometers. And what if I said how many meters into that? And if you run cross country, you know. But you can use this chart to show you. So here's what I do to use the chart. I'll change this and see if this happens. So right for 5 kilometers, you start right here with the K, and you start at the K for kilo. And you want to find out what meters is. Meters is the base unit. So you're moving from this K here to the base unit there. So that's you just count the steps. 1, 2, 3 steps to get there. And what you do is you move your decimal point 3 places. 1, 2, 3 places. So in this case, we would add 3 zeros, and 5 kilometers is 5,000 meters. Okay, you just count the steps on the chart, and then however many steps you move the decimal point in the same direction that you counted the steps. So if I said I had, I don't know, 25, I'm going to go back to this. Let's say I had 2,500 centimeters, and I wanted to know how many kilometers is that. Well, you can just count. You're here at centi, back to blue. At centi, I'm right here, right, for centimeters. So centi is 1, 2, 3, 4. Sorry, messed it up. Don't count the step you're on. It's 1, 2, 3, 4, 5 steps to the left from centi to kilo. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is 0.025 kilometers. Make sure. 1, 2, 3, 4. Yeah, okay. 0.025 kilometers. So you get the idea. You can use the chart to move between numbers and convert them. And really, there's lots of spaces, and a lot of these have different words as well, like some of the ones that I didn't label, but that's not important really for us. The most important part is the interior 6 spaces from kilo to centi, to milli. Let's get it together. There we go. Those 6 spots are the ones that we need to be able to convert in our heads fairly easily. Okay. And you'll have a worksheet with this later on this week. Okay, we often pair the metric system with scientific notation. I think we've been doing this for a long time, so I don't know how much time I'm going to spend on it, but it's nice to say, instead of writing, you can express really large numbers and really small numbers with the metric system. It's nice to pair these two things together because you can use scientific notation to reduce the amount of writing that you have to do. And I know you're very busy and important teenagers and no one likes to write anything. So here's what I usually do for that. If you have a number that's really large, like let's say 25 million, that's million, like that, and you want to convert that into scientific notation, what you do is you just move your decimal point until you get a number between 1 and 10. So you would start your decimal point here, 1, 2, 3, 4, 5, 6, 7 spots. And so your new number then is 2.5 times 10. And since I moved this to the left-hand side, then my number is going to be positive. This number is bigger than 1. So I said 7, I think. 2.5 times 10 to the 7th. That's how you convert them. If your number is smaller than 1, let's say your number is 0.0000718, okay? You move your decimal point until you get numbers between 1 and 10, so 1, 2, 3, 4, 5 spots there, and I would end up with 7.18. So I'd have 7.18, and then I moved 5 spots, so times 10 to the negative 5th. The negative number indicates that you're less than 1. So negative number means less than 1. Positive exponent here means you are greater than 1. And that's how you use scientific notation. Again, we don't need to focus too much on it. I mean, I think that you've used it before, but we'll have a little bit of practice for you on the next worksheet for you to look at this as well. So I blew through this because I'd already done it once, and I hope that it made sense to you. If not, of course, send me emails, ask me questions. Anyway, it's been a good chat. Best of luck to you. Bye.